Okay, welcome to Chapter 4 review, Modeling with Quadratics. So go ahead and pause the video and read the problem. Alright, so we need to sketch a graph of the ball's path. How long will it take the ball to strike the ground? So basically we have an even function with a negative coefficient, and so it's going to be an upside down parabola. So basically we want to know how long it takes to reach the ground over there. Right. And h is the height of the ball, so how long will it take to reach the ground? We are going to set the height equal to 0. So we have that. And then once we solve for t, which we're going to move these questions over right now, when we solve for t, that will give us the time it took for the ball to reach the ground, because the height at the ground is 0. So we can make it easier on ourselves. Since we're solving, we can divide everything by 4. Actually, we can divide everything by 8. And 0 divided by 8 is 0. Negative 16 divided by 8 is negative 2. T squared. 32 divided by 8 is a positive 4t. And 8 divided by 8 is 1. All right, so that does not factor, so we will have to use quadratic formula. So you take a triple challenge. A is negative 2, B is 4, and C is equal to 1. And you're going to plug that in for your quadratic formula. Negative b plus or minus b squared minus 4ac all over 2a. Okay, so when I plug them in, b, negative 2 and 1, and negative 2. Alright, so now I'm just going to simplify that until I can't simplify it anymore, and since it's a word problem and we're looking for time, we're going to plug our result into the calculator. But first we'll simplify. So we have negative 4 plus or minus 16, and then I have a negative 4 times a negative 2, which is a positive 8, times 1 is positive 8, all divided by negative 4. And then when we have that, we'll have x equals negative 4 plus or minus, and then when I simplify that even more, I'm going to get a positive 24, and then I'm divide by negative 4. So now I'm going to split my two solutions apart. So I have negative 4 plus the square root of 24 divided by negative 4, and that is equal to negative 0.22, which we can't go back in time, so that is definitely not a solution to our problem. So the next one is negative 4 minus the square root of 24, all divided by negative 4. And so when we simplify that, we get 2.2 seconds approximately. And that's, so in about 2 seconds, the ball is going to reach the ground. For our next two questions, we need to know what time is the ball at its maximum height. So again, it looks something like, actually, our parabola looks something like this, right? So max height would be right here. Here's our time. So we need to figure out what the time is and what our max height is. So maximum height is when we have the axis of symmetry. So we're going to use negative b over 2a to find our maximum time. And we're going to go back to the original equation, so not the one we divided by 8. And so when we do that, we get a negative 32 divided by 2 times negative 16. And then when we simplify that, we get 1. So in 1 second, it's going to reach its maximum height. And then to find the actual maximum height, so this is 1 second, we are going to plug 1 in for our t's. So we're going to get y is equal to negative 16 So when I plug 1 in and simplify, I get negative 16 plus 32 plus 8. And so when I simplify that, I get 24 feet. Right, so in 1 second, it's going to reach its maximum height of 24 feet. And that is the end of example 2, or example 1. Here's example 2, so go ahead and pause the video, try to figure out what's going on, see if you can answer the questions. All right, so we want to find the length of the frame, and my answer will have an X in it. So the length of the frame, so if here's the length, I know this part is 11, and I know the widths are X. So the length is going to be 11 plus 2x for the entire frame. Okay. The width of the frame is similar. So here's the frame, here's my whole frame. This part I know is 6. The other part is x. So on each side I have a width of x by the 6. So the width is going to be 6 plus 2x. Right, now we need to write an expression for the area of the steel frame and solve. So we are going to find the area of the whole entire thing. So we're going to find the area of the whole entire frame. And then after that, we'll find the area. That we know the area of the frame is 28. We'll find x after that. So area is length times width. So we have our width is 2x. Our area is 11. Our length and width, length is 11 plus 2x. And our area, well, we have to add two numbers together. So inside, 6 times 11 is 66. We know the inside is 66 centimeters squared, and then the area should be 28 centimeters. So we need to add 28 centimeters to that. All right, so I'm going to FOIL this out or put it in a box and multiply. When I do that, I get 66 plus 22x plus 12x plus 4x squared. And that, we'll just keep that as 66 plus 28. Right, so to put it in standard form, 4x squared goes first. I add my like terms, and I get 34x plus 66 equals this. And I know I have 66 on both sides, so if I subtract 66 from both sides, and actually I want to put it in standard form, so I'll subtract 28 as well. On this side I get 0, and on this side I have 4x squared plus 34x minus 28. This added up to 0, and so what I have left for my constant is negative 28. And then from there, let's see, they're all even, so I can divide everything by 2. So I have 2x squared plus 17x minus 14 equals 0. And then from there, I want to use the quadratic formula, okay, because it does not factor. So x is equal to negative b plus or minus b squared minus 4ac all over 2a. But first I gotta take a triple challenge and figure out what a, b, and c are. So a is 2, b is 17, and c is negative 14. Right, so I have 17 here. Oops. I have 17 here, 17 here, a, and then c, and then a again. All right, so I simplify that. I get negative 17 plus or minus 289. And then I have two negatives, so negative 4 times 2 is negative 8, and negative 8 times negative 14 is 112, and all that is divided by 4. And then when I simplify again, I get negative 17 plus or minus the square root of 401, all divided by 4. Okay. So my two answers now is I have one negative 17 plus 401 divided by 4, And when I put that in my calculator, I get 0.75, and that's in centimeters. The other one I get is negative 17 minus the square root of 401 divided by 4, and that's going to be negative 9.25 centimeters. So I can't have a negative dimension, so I'm going to cross that one out, and that is my final answer. So each x is 0.75. So when I go all the way back to my problem, what should the width of x of the metal be? And that should be 0.75 centimeters. All right, for my next problem, pause it and try to figure it out, or unpause and listen to me. All right, so John's hitting baseballs where he tosses the ball into the air. His hand is 5 feet above the ground. Right, so John is the starting point. So John is kind of like the y-axis, which means the y-intercept is 5 because that's where John is tossing the ball. And then when he hits the ball, it falls back to a height of 4 feet. Right, and it's modeled by this equation. So how much time will pass before John hits the ball? Okay, well, he's going to hit the ball at 4 feet. So what we want to do is set h of t, which is our height, to 4, and then it's going to equal 5 plus 25t minus 16t squared. Right? And then once we solve for t, we can figure out how long it will be. So if you can do this, pause it and set it, put it in standard form and solve. If not, just watch me. All right. Okay, so let's put it in standard form. So I'm going to subtract 4 from both sides, and then I'm going to rewrite this. So negative 16t squared goes first, 25t is in the middle, and then plus 1. Okay. And then we're going to go ahead and solve for t. So we're going to use our quadratic formula again. Negative b plus or minus b squared minus 4ac. Oops. 4ac, and that's all over 2a. And then with my triple challenge, a is equal to negative 16, b is equal to 25, and c is equal to 1. So I have 25 here, 25, negative 16, c, and negative 16. Right? And then we'll find the maximum height in a little bit. But to carry this on, x equals negative 25 plus or minus 625. And then a negative times a negative is a positive, times 1 is a positive 64, all divided by negative 32. So x is equal to negative 25 plus or minus 689, all divided by negative 32. And again, we're solving for t, so technically that should say t, but negative 25 plus the square root of 689, all divided by negative 32. So when I do that, I get 20.5, and that would be in seconds. The other answer is negative 25 minus 689, and that's divided by negative 32, and that is equal to 1.6 seconds. So it seems a little bit more reasonable that he's going to have 1.6 seconds to hit the ball. And then what we want to do is find the maximum height. So we found when he's going to hit the ball. Now we want to find, we're answering this question, what is the maximum height that the ball attains? So we need to find the axis of symmetry, and then once we do that, we're going to plug it in. So the original equation we're going to use. So h of t is equal to negative 16t squared plus 25t plus 5, so that's in standard form. And then to find the line of symmetry, we're going to have negative b over 2a So we have 25 and negative 16. And then that's 25 over 32. So in decimal form, that's approximately 0.781. All right, so that's the line of symmetry. And then I'm going to take that and plug it into the original function. Okay, and so your calculator uses order of operations. So if you want to plug it in all together, make sure you use parentheses, but we need to square this first before we multiply by negative 16. And then when you do all of that, you should get 24.43 feet, right? And that's the maximum height, right? If you need help with that calculation, I can break that down in class for you tomorrow. But I will see you all tomorrow. Have a good night.